Okay, here's the first proof that we're going to do together. Notice it's not a fill in the blank. So you're going to help me come up with some ideas. Okay, I didn't run these off, so on your own paper. Guess what?
So is this what we're doing for our lesson today?
This is our lesson today, yes. This is today's lesson. Continuation from yesterday. Just a little bit more difficulty. It's the same lesson. 5, 4 as yesterday. Okay, help me do the proof. I'm going to make it in a 2-column form. What goes on the left side? What's the heading for that column? Statements. And on the right side, reasons. So statements and reasons. We're going to try and get those two triangles congruent. Okay, what's something that we know in this problem? Did I put something in? Okay, he's saying segment DF is congruent to segment FG. How did you know that, Zach? It is given. Update your picture. Segment DF congruent to segment FG. So there's a pair of sides congruent from the triangles. What's something else we know, Sam? Okay. Parallel to HG. Reason? Update the picture, arrowheads, DE, HG. Okay, now think about what that means. Can we get congruent angles or congruent segments from parallel lines? Lucy? E and angle H, what's your reason? Okay, lines parallel? Yes. Okay, so angle E is congruent to angle H. She said alternate interior angle theorem. So I'm going to put an A beside that because there's a pair of angles that are congruent. Update your picture if you didn't. Ideas. Gavin, something else we know about that picture? Tell any segments or angles that are congruent for a reason.
D and G.
You said, what, D and G?
Yeah.
Okay, he says angle D. I better hear, what's your reason going to be?
They're the same.
I don't know. He's coming up with angle D congruent to angle G, but his reason is they're the same. That doesn't sound like a good reason. What's a reason? Alternate interior angles. Because you've got the parallel, so slanted on the transversal, and then the other parallel. That Z, the corners of the Z are alternate interior angles. So angle D is congruent to angle G. Same reason as the last one, alternate interior angle theorem. And I'm going to put a little A out here. That's another pair of angles. So we have two pair of angles and a pair of sides congruent. What arrangement is it? Do you have something more? Okay, what was your reason going to be? Vertical angles theorem. Okay, I'm going to erase that back out because I think we can stop and not have to use that, but you could have given me that before, like Gavin gave his, and done this a little bit differently. This one could be done more than one way. If we stick with the first things that were mentioned, are the two triangles congruent? Why? two angles is the side between them? No, so it would be angle, angle side, congruent theorem that supports what we're trying to prove. Triangle, DEF, congruent to triangle, GHF. And as Shay mentioned, there could be variations. If you were doing that one on your homework, someone might have used the vertical angles instead of both alternate interior angles. Give me a thumbs up or down if you made sense out of that one. Right, and do you think you could do it yourself? Thumbs up or down? Pretty much, okay. All right, questions to ask before we go on to another one? Okay, do you have that sheet of common reasons that I gave yesterday? Just set that out on your desk. Got everything, Andrew? Got your notes from here or not? Can I go on? Okay, let's try another one. What's that upside down T mean? Perpendicular, which really means 90-degree angles or right angles. Okay, so we've got some right angles. We even have right triangles in this one then. Let's see if we can get the triangles congruent. Jaden, you get to pick the first thing this time. Reason? Start writing the wrong thing. Segment PS congruent to segment QR. And that was given. PS to QR. McKenna.
Segment PS is perpendicular to segment S1.
Given. Sydney. What'd you say that symbol meant? Perpendicular. Segment QR. Okay, now what's that mean? I'm gonna say we need to use the definition of perpendicular. We have to interpret what perpendicular means. Lizzie?
Rectangle S
Okay. And how about Q also? So angle S and angle Q are right angles. Angle S and angle Q are right. Can't spell right. Angles. So this is a right angle, this is a right angle. Okay, can you think ahead? What else are we going to have in this proof? Reflexive property. So why are the triangles going to be congruent? Hypotenuse leg. Okay, so the reason I wanted you to think ahead is if we use hypotenuse leg, we have to say that there are right triangles. Right now I said there's right angles. So before we leave that sequence of thoughts, let's put in that there's right triangles. Because if there's right angles, a right angle in a triangle makes it a right triangle. Right, yes. Morgan, what do you want?
And you know, there's like I say that PR and SR are congruent to the vice versa, because right now we're not allowed to say that it's a right triangle, or a right, or hypotenuse line.
Right, I'm not doing hypotenuse leg right now. I'm just gonna say that triangle PSR and triangle PQR are right triangles. Reason is definition of right triangle. So all I did was identify the right triangles, so that we could use hypotenuse leg in the end. I need a little bit more room, I think. Just get a little bit more space. Okay, so then we've stated the legs congruent. We need to get the hypotenuses. That's your segment PR. Congruent to segment PR. Many of you were saying reflexive property of congruence to be completely correct. Now we're ready to say the triangles are actually congruent. So 7 is triangle PSR is congruent to triangle in the matching order. PSR would go with RQP. I think I've got that written down wrong. I don't think that's in the right order. PSR would go with RQP. Never noticed that before. RQP. And it was because of hypotenuse leg congruence theorem. Those were the legs, here's the hypotenuses, and here's where we said that they were right triangles. Want that one thumbs up or down? Make sense? Okay, you could do it yourself. Maybe a little bit harder with the right triangle part in there, but whenever we do hypotenuse leg, you have to have right triangles. Okay, finish up those notes, and how about one more example? I think I'll come back to that again. Everybody else is finished up? I can have you do a screenshot or something like that, so that you get that. Let's do one more example and then I'll flip back to those so that you can get those. All right, K is the midpoint of segment JM and NL. Let's try and get these triangles congruent again. Statement, reason. What's line 1 probably going to be? Right. K is the midpoint of segment JM and segment N. And that was what's that mean? no, it doesn't mean that. What's the definition of a midpoint? If a point is the midpoint of a segment. Carrie.
KL are congruent, and then JK and KM are congruent.
Correct. And that's not what you said, was it? Okay. Right, it's that those pieces, those halves on each one are the same. Okay? So segment NK is congruent with segment KL, and also segment JK is congruent to segment KM. You could put those on separate lines or together, whichever you prefer. So that gives me two sets of sides that are congruent. What else can we come up with? All right, we can use the vertical angle theorem. Natasha, which angles are vertical that are in the triangles there? Okay, which angle J and angle M? No, those aren't vertical. Vertical angles have to be hooked together, formed by the same two lines. So look around the middle of the picture. The angle over here and the angle over here are the ones that we want. I can't say just angle K, because there's a lot of angle Ks. So give me three letters. Start on the side. Angle J, K, N. Would be this one. What would be the other one, Natasha? Okay, now. So I need to say angle JKN is congruent to angle LKM. Vertical angle theorem. That's a pair of angles that are congruent. Are the triangles congruent with what we've said, or do we need to keep going? They're congruent. What's our method? Side angle side. So triangle JKN is congruent with triangle. Did I match them up right this time? JKN, MKM. MKL. And we said it was side angle side. Congruence postulate. Okay. All right, getting more the hang of it? All right, so you got three more examples today. Let's write down which ones you'll do out of the book as soon as you're done with your quiz today. Page 261. Now, many of those are just diagrams to tell whether they're congruent or not, but I'm going to put a note here. I want you to actually write a proof like we were just doing up here. I want you to do a proof on problem number 18 and number 20. So use what's marked in the diagram as what's given. Try and prove the two triangles congruent. So it's not exactly written like my directions here, but we can interpret it that way. What's marked in the diagram is given, and you're trying to prove the two triangles congruent. Okay, so page 261 and 263 will be your assignment after you're done with the quiz. And Andrew, do I need to go back? Okay, you got this one?
Yeah.
Okay. Just the next one, scroll it a little bit. That works. Yeah, do you need the first one? All right. So put things off your desk.